Now we will try to map the boulder. So perform a task that you probably didn't have done before. And I'll try to be as much clear as possible, but please interrupt me if you have any doubt about the explanation. So the idea is that your work will not be limited to an exercise here, but can be used also for science, for contribute to the science. So if you didn't already, if you want to do so, I mean, you're not, there is not compulsory to do so, but if you want, please, I ask you again to fill out the preliminary form, just to be sure that we can track the information and we can use the data you produce. I will remember it also afterwards, but if you want to be mentioned in the paper, it will come out from this work. And if you want to receive a certificate, you just need to perform the task we will do now, and the second area I will propose for you for afterwards, but I will get into detail afterwards. So basically, what we want to do, I mentioned before, we want to interpret an image. So we will have a raster that is, I will change that. Okay. I will jump from PowerPoint to QGIS from time to time. Basically, we want to interpret this image here, not all the image, just one area of these that are marked over here. We are in the Mare Crisium on the moon, and the image has a resolution of 0.5 meters. As you can see, it's quite detailed. So, back again. We want to interpret this image and obtain a bunch of circles that corresponds to the shape of the boulder that rests on this surface. First of all, we need to be clear about what is a boulder, how its shape can be defined, what we want to adopt as an approximation. A boulder, when rests over a lighted area, has an illuminated area, that is the side that is exposed to the sun or the source of light, in our case it's the sun. A shadowed area, so the area that corresponds to the boulder but is not lightened, and a casted shadow. This shadow here does not belong to the boulder, but it is dropped upon the surface of the moon. So here is a couple of graphs that illustrate how this works. This means that we can approximate these shapes only by defining 2 points, the center of the boulder and the maximum radius. Or, since we will use open crater tool, we will decide the diameter, but still you need to define the center and the maximum radius because there can be different diameters according to the shape of the boulder. For example, here you can have this and this, or maybe all the intermediate ones. So here is how in the end it will go. You have image, you can perform different type of stretching, you can try to enhance what you can see, but in the end you will end with a vector files that has that gathers all these shapes of the boulders. Moving to QGIS, you can see here in the list of the layers that I place a mapping examples. If you zoom here, this place over here, there are some boulders that I already mapped. The area is about this one here. And you can always put it on, put it off, take it on, take it off to just see how hard these examples. I would like to stretch the fact that all the boulders must cast a shadow. So if you have something that can see a boulder but has no shadow, I don't know if I have anyone here or yeah, maybe this one here. You can see something that is light but has no shadow almost, so it's not a boulder. you will see that at the beginning it can be quite sketchy, but the more you do, the more you get familiar with this. You see here? You can just try to look at these and see how they fit with your experience, with what you think that can be or not can be a boulder. Going back a bit to the presentation, not everything, we are not interested to everything. I mean, if you try to map down to the pixel size, you can introduce excessive errors. So to avoid this, the threshold for having a valuable boulder is 4 pixels. It is an image-related variable. I mean, it's not a difference if you have an image that is 0.5 meter pixel or 10 meter pixel. The size of the acceptable boulder is always 4 pixels because you need to be able to appreciate the illuminated side, the shadowed side, and the casted shadows. But if you are in doubt, don't waste your time. Don't try to count a pixel and see is it here, is it not. Just map it, because in the end, since as you already seen by Thomas, you see how the size of the shapes are always calculated. So we can remove those shapes that are below the threshold. Is it easier to just map everything you think is a boulder rather than spend a lot of time in thinking about this is enough or this is not enough? Please consider that commonly during an hour, you can have up to some hundreds of digits, let's say 300, 400 digits about an hour if you are a trained operator. I'm giving you some examples. So here is basically the same thing I already showed you on QGIS that you can interact a bit more, but I just put it here because if you want to have the side of your image when you are interpreting it, you can just press Alt-Tab and see what an image look like. But let's say, let's try to think about all the possible shapes. This is the most classical boulder that you can encounter. It's almost circular, is as a clear side illuminated, a little bit of shadow here, the casted shadow. So it's the best example of a boulder you can encounter, and it should be easier to map it. But then you can have something that is not exactly rounded as it was this one here. You can have elongated shape. What about this? I mean, we have a minimum diameter, a maximum diameter, and everything that stands in the middle. So you want to go for the maximum diameter in these cases. Don't think about all the intermediate ones, just go for the maximum, because this allows you to absorb all the errors that may arise from an underestimation of the sizes. And then you can have overlapping boulders. Since those boulders derive from an impact of an asteroid, they have all radial trajectories. And this means that one boulder can roll, and then another can roll and be stopped by the firmer one. You see this one here is bigger than the other, so most probably this one rolled and just placed side of the other because you cannot overtake it. In this case, don't worry, it's not a problem if they are overlapping, just map it. We are not interested in the superimposition of one on another because the assumption is that all these boulders are derives from the same event. We are not, as was for the credit accounting, for example, we are not involving post-collision processes that may cancel this. A boulder is very small, is very fragile, so any kind of process that may involve superficial flows or resurfacing of the surface most probably erase or cover the boulder, so will somehow disappear. So if you see a boulder, just map it. Here is an example of what I was saying before. This one is 4 pixels, so it is within the the threshold is acceptable. Is this one here? And then here, for example, we have another that is probably a boulder because I see a lighten area, I see a casted shadow, but it's just 3 pixels. So it's not, it will not contribute to the statistic. But don't worry. If I'm watching this area, most probably I will circle it, map it, and then cancel afterwards. Remember, as written here, I probably am a bit redundant. I can go over the same concept more over and over, but if you're in doubt, don't waste any time. You're doing a task that is technically easy, maybe not conceptually easy, but it's technically easy, so don't waste any time and just map it. Possible errors. The shadows, basically are the shadows. Since the image has been taken in a specific moment, in a specific instant, all the shadows must be aligned in the same side. Here, you can see that all boulders have the lightened side on your right and the shadowed side on your left, meaning that the source of the light was basically something here towards the southeast. Here is not the best possible example, but you can see that this feature here has the shadow on the southeastern side and the illuminated side on the northwestern side. Is it the opposite? Meaning that if these features stand above the surface, this one here is incised in the surface. The shadow is the other way around. So this one here, you want not to map it. I mean, these are the examples. Then I will move to QGIS. But just a last note: you want to be sure to cover all the area you want to map. How can you do that? You have to adopt a strategy that ensure you not to forget any side of the not any side any areas outside your mapping project. So you need to go this way, like a worm, like the plane move when acquires a photographic coverage of the surface. You go one direction, then turn, go the opposite direction, then again turn and go and go and go until you cover all the area. Each time you move, you want to be sure to have an overlap area when you move along the line, and you want to have a side lap superimposition when you go on the second line. This way you will not forget any area. You will not left any area out of your mapping. So this is the theory. As I said before, if you want to contribute to the project, if you want to be mentioned in the project and receive a participation certificate, you will have to perform the 2 mapping. Today we will do just step 1, 2, 3, and 4 on area 2. You will see this on QGIS now. If you want to receive this certificate, you just need to do the same thing for the area 1. So let's try it. I don't know if there are any general questions right now. Otherwise, you can move to QGIS and try to.
Let me see. So there was a bit of questioning about whether this is the planetary mapping certificate. No. So for the winter school, you will get the planetary mapping certificate for the completion of the map of an area on the Venus dataset that we provided and on the Mercury dataset that we provide. This is a certificate of contribution to a research project, which is an additional thing. It is optional. You can do this and cannot do, the mapping, so you will get just this certificate. But if you want a planetary mapping certificate, you have to complete the maps. if you want to have also this certificate and dimension in the research project, you have to complete this Boulder counting task. So there are two different things. Okay. And we have another question about is there an upper size threshold? So boulders which are too big to be considered as boulders. So we mentioned the lower size threshold, which is 3 pixels, more or less. And this is to basically the 3 pixel is the rule of thumb that enables us to identify the shape of an object. So below 3 pixel, or say 3 pixel, the shape is questionable. Higher or upper than 3 pixels, you can do it. The upper threshold, I don't
Basically
know.
doesn't contribute to the statistic
Yeah,
because
you
it's
can map super large things, but it will be an outlier in the statistics, no?
yeah, exactly.
Yeah.
The, basically, in the very beginning of my activity on this, I was really concerned about threshold, about which is the minimum, the maximum, is it true, is not true. But when you count hundreds of these kind of features, it really stick out when you have an outlier. If you have a boulder that is, let's say, 100-meter large and all the others are from 1 to 10, does it out to evident that this is not contributing to the same event. You can have boulders belonging, deriving, sorry, from two different processes that superimpose one another. And this may be tricky to identify, but in this case here, it's more, it's clearer. So we have just the impact of the crater and the boulders deriving from this impact here. I'm showing you. Yeah, so you have just this crater that created um, all these boulders that you can see here. Other questions? Otherwise, we can go. Cannot hear you, Ricardo.
I'm just looking at some. Um,
Or if you want, I can start, but you can jump in whenever.
we have if there are any task descriptions somewhere for the maps we have to deliver. Yes, I think I have answered in a separate thread. But there's a GitHub page. You will find it in your uh, introduction kit with the big email that we sent you. There's a GitHub page with all the information about the tasks. I will paste in the chat the example for Mercury, and for Venus we have to upload it, but it's essentially similar to the one of Venus. So it's terrain recognition, different types of units, linear elements like folds, fractures, superposition, like who came first, who came later, and so on. And for this particular activity, please follow the indications of Sandro. And there will be actually there is already the PowerPoint uploaded in Zenodo, so you can have a look also again to the recorded lesson and to the presentation where there are all the relevant links that anyways I have put in the chat of the Moon citizen mapping activity. We have another one. Yes. We have another question, Sandro. Could you explain, please, how then you will merge our counting? Just curious how technically it is possible to do. You will put all in one layer automatically, or what is the processing that you will do after you receive the files?
Okay, this is not exactly my area of expertise, but we had a real long chat about this. We will not merge your data one with the other. We will take them separately. So we will have like a very big pile of layers. And then the area corresponding to boulders in each layer will be compared over this pile. And the boulders will be identified as real boulders when exceeding a certain threshold of identification. This is for the, is it a boulder or is not a boulder? Then you have the problems concerning the size of the boulders. Someone will probably underestimate, someone will probably overestimate, and someone will do exactly the right thing. But since we don't have the ground truth about this, it's just about statistics and it's just about skill. So someone of us that has a long experience about this will map um, a training area, let's say, with a real focus attention with a long of time, and then this area will be used to compare with all the other layers and see how the specific operator perform on this area. And this performance test will allow for the tuning of the whole layer of that operator. But the whole project is about this. So we are now in the first collection of the data. You are the first operator to do so. And it is possible that the strategy will change as long as we will obtain the data from you. In the question time this afternoon, I asked for a 5-minute slot just to present you the comparison of the data that will be collected today. So you will have the feeling of how you perform in comparison to your operator. You don't have I'm this one, you are this one, the other is this one, but just all together and see how you perform as a group. Probably we will see some outliers. Probably we will see some concordance in between you. But I mean, we'll see. We'll see. It's just the first test about consistency between different people.
Right. Sandro, also, yeah, this is another interesting thing to mention. So, if you complete the activity by, let's say, in the next hour or so, and you put them in the upload page, Sandro will process the data during the seminars, and then you will see the results straight after the seminars are ended. So it means that you will see directly the effects of your mapping. So it would be, I think, quite cool thing to do. Actually, I also would try to do it in the next hour. So
yeah, for sure.
And also, Sandro, another maybe thing that you can demonstrate is what you can you can do in practice. So you map the boulders, you map all the things. So can you show us an example of how you do it and how then you upload the files in the platform?
Yes,
in the upload page, because you see there are 6 files. Once you create a shapefile, we created tools. Actually, there are 6 files created. One is the database containing all the records. One is the actual shape, so the circles, and other additional files. You have the projection file. You see here there are CPG, DBF, PRJ, etc. We need all of them to be able to perform then the statistics. So in the upload page that you see linked below, actually there are fields, and in each of the fields you have to upload one of these different files, so you don't mistake, so you don't miss one. Sometimes when people exchange shape files, they forget one of these or multiple of these, and then it becomes not usable. So can you give us like a full demonstration of like a mapping activity and then upload in the page, so we can see how it works? Thank you.
Then I can maybe show the uploading of the results also towards the end of the activity, just to
Well,
remind you of
before we start, we have another question. When is the deadline to write the files? So today you can do what you can, but the deadline, correct me if I'm wrong, is the same as the mapping activities for receiving the certificates. So 31st of March. So to give you the possibility to do it either in real time or to spend a bit more time, and also to enable the people that are following asynchronously the school, so not in real time, to do the task and perform the activity. So 1 month and a half from now, the 31st of March is the deadline.
Yes, correct. As for today, we will focus on, here, we will focus on area number 2, that one on the south. At the beginning, I thought that you will be as many enough to cover both areas, but it is better, since I saw the numbers, it is better to focus just on this area over here. It is important for me to show you consistent data that you complete this area. It is probable that you will not have the time to finish this by, let's say, 1 hour or so. So if you want to spend 10 more minutes or doing it afterwards, I just need the data by, let's say, 2 p.m. to be able to elaborate them and show you the result for the Q&A. But most important, if you didn't finish the area, is not a problem. You can do it afterwards, but don't send the data that are incomplete. Otherwise, it will mess up the statistics. So I'm showing you how to map the boulders, all the workflow. As you can see here in the layers, you have the background map. This has already been stretched to show you the best possible lighting of the area. Then you have those that I call the supporting materials, meaning that you have the area that are the test areas for the activity, and the mapping examples that are all these boulders that I mapped over here. So these 2 layers is just for your reference, for your check. Then we have the 2 layers that are Moon Boulder mapping area and Moon Boulder mapping nickname, name, surname, crater. And those two works with Open Crater tool. That is that one that you already saw with Thomas. So I will use this one here. Since you will work on this, I will show you what is about here. So is let's say I'll start from the upper left corner. I'm deciding the resolution, but well, I will spend about 5 minutes on this, just not to.
Sandro, so we are mapping on the southern area, the lowermost area.
Yes.
So can
Area
you show
number 2.
us there, so not to make confusion?
Okay, I will not.
Please.
Yeah, because I wouldn't try to give hints too much.
Ah, okay,
No,
okay.
not a problem, not a problem. I can do that. I start from the lower left corner. Okay, so this resolution here is enough to me to see the pixels. So you can see here, for example, these are 3 pixels. I will left open, away from the statistic, but it's not a problem. So I have my 2 layers here, and just start with the Open Crater tool. I selected the crater and just clicked on the tool, and then I start mapping. Let's start from the easier ones, the big ones, this one here, and then I show you how I do this a little bit slower than I do usually. This one here, for example, is 3 pixels. Most probably will be canceled during the post-processing, but it's not a problem. As you can see for the placement, I've been keeping the lower boundary of the mapping areas inside my my screen, as well as the left boundary. And then I will just try to be a little bit more quick. As you can see, I'm trying to be precise, but not really being mad about that. Okay, more or less, I have mapped the 4 pixel here, so I can move to the next vision. I'm keeping on the left the last boulders I mapped, so I'm sure that I have side lap with. Sorry, this one here is not good. Okay. So I'm sure that I have side lap and not leaving any empty areas. So here are a lot more than before. Not doing all of this, just to show you this one is really big, for example. Just to show you the workflow. Okay, I think this can be enough. You see this over here, overlap the shapes overlap one another, but it's not a problem, not my concern. Okay, so I did all of this. If I go to the attribute table, you can see that I mapped 39 boulders, let's say 40, just for my idiosyncrasies. Okay, 40. So I have here all the diameters, coordinate of the centroids, the tag, whatever. Now, what I have to do is right-click, export, and save feature. I want them as a shapefile. I have to decide a name. I'm leaving here. As you can see, the name is this one here. I can keep more or less the same. Basically, what I want to have is my nickname, then my name and my surname, underscore, right there. Okay. You can leave all the options on as they are, it's not a problem, and then press OK. Let's
Okay,
see.
we have a question,
Yes.
an error that might arise. Somebody says, I always get the message wrong shapefile at the top. So let me make it try. Maybe you are selecting the wrong one.
No, this is possibly because you downloaded the version number 2 of the training material.
So you updated it?
Can't. But you can easily solve this by create a new shapefile.
No, I will link the new project in the chat. But essentially you can use the same link. It's been updated. Now there's version 3. It was updated a couple of days ago. So please download the new version. It's the same link as before.
Basically, is the same. Is just this vector file over here that changed.
Thank you, Sandro, because this might solve some of the issues. I will also now try myself to map the area.
You want me to show also the uploading?
Yes. Please.
Okay. So now I have exported all of this. If I go to, okay, here I have my folder. Within the folder, you see you have 6 different files: CPG, DBF, PRJ, QMD, SHP, SHX. Now I'm copying, you can see here, I'm copying this link that is the upload page. And now I'm choosing upload my files. Going to my files. I'm selecting all of them. Okay. QMD is not allowed, possibly. QI. Okay. Ricardo, is there a little bit of problem over here?
There's an error.
Yeah, because they allowed for QIX and not QMD.
Now it's going to. So QEX.
Is QMD the file, and they went for QIX.
Okay, this is weird because
probably it's my fault, so not sure about that, but
same.
I'm trying to see if it's really important to have the QIX, but it would be better to have so.
So you need the QIX and not the QMD.
No, I need the QMD and not the QIX.
Because in OpenCreator tools, I see no QMD actually. Are you sure?
I mean, I exported.
Okay, now I understand why, because you exported. Yeah, the QAX
I
is
can
in the
try also
no,
with
no,
this
no.
one
You're
too.
right. You're right. We will change it. Okay.
Okay. Can we keep the workflow as it is?
Anyways, the QMD is not so relevant because it's the styling. So
Yeah, it's the styling, but I think it's already uploaded, so you don't have to confirm. Am I right?
I think so.
Let me check. Yeah, I went in and the files are already uploaded, so everything
Okay.
went fine.
Yes.
Okay.
Perfect. And they're still workable also without QMD. But anyways, we will change the website, and you will
Yeah,
get
I think it's possible.
the correct
Anyway,
the correct.
yeah. Anyway, be sure to have the nickname and name and surname. This way we can pair your shapefile with this nickname to the form that you already filled out. So we can pair the data and see which are the possible problems arising when mapping. So I think that as for the beginning, this one is all the information you need to have. But if you have any question, please jump in, and maybe I can show you some specific cases as we proceed with the mapping. Riccardo, I don't know if there are any questions. Otherwise, I
Yes,
wish.
there's one. Um,
Yeah.
one of the 6 files I've exported is .sbn. I guess it's not allowed.
Which one? Sorry.
.sbn. .sbn.
SBN. Sorry.
Can
SBN.
you redo the export phase? So we will.
Yeah. So over here, right click, export, save feature as. I'm going a little bit slower this time. Over here, be sure to have as a reshape file. That may be the problem in this case. Then choose your name. And this time I will make just a two. When you decide the name and have the format as a shape file, you can leave everything as it is and press OK. You can see I have now 2 exported files. And if I go to the folder, let's go this by the name, SHX, SHP, QMD, PRJ, DBF, CPG. Yes, I mean, I don't.
Yes, that's it. I also made a try. So eventually, either you are exporting something different,
Maybe a
or
different format.
I don't know. So when you right click to export, be sure to select .shp as the shape file.
As a shape file, this one here.
We have another question. Could you show please again how to rename and save the shape file? Where we are making changes. Okay, show it to another time also when you rename it.
Okay.
No, sorry. This is using ArcGIS, so this is why it's not working. No,
But
you have to use QGIS because this plugin is for QGIS, and we need this to use the Open Creator tool because embedded into the attribute table of these shapefiles there are
Yeah.
other elements that we will use. So you can show us, Sandro, there are diameters,
Yes. All of these are
coordinates.
calculated each
So,
time you digit something. So you see here, for example.
so this is why we need to use this particular plugin into QGIS and not a simple circle strip file in another GIS like avatar.js, because we need the diameters. Of course, we could calculate them, but this is more straightforward also to perform the statistics
Yeah.
during
You
the
see,
lunch break, let's say.
yeah, you see the last one is this one here. It is fairly bigger than the other, so you can easily recognize. If you select, it will appear. You can also zoom into this one here.
By the way, the upload page is corrected now.
Okay, let's but
So
I think so. Yes, perfect. I can try to upload the
yeah, show it to another time. So then when we edit the lesson, we also have the correct version.
Yes, so you can find the link in the presentation. That is this link over here. So just simply copy paste.
And we will also link the presentations into the program or in the website. When you click on the name of the lesson, you will jump to the presentation.
Okay, perfect. Then when you are here, you click upload your files. A window opens, then you have to surf towards the folder where you have your files. Just select those that belong to the shapefile you exported. I mean, these belong to the second export. You see the two over here. This belongs to the first one. And then just click open, okay, or whatever your language is, and it will add them here. As long as you see file successfully uploaded, then it's fine. If you want to have a try and let me know that this try is not that one that you consider as definitive, I can check and erase your attempts. You see here are the files that have been uploaded in the manager.
Okay, we have another question, Sandro.
Yes.
It is possible to delete a shape if I misclicked or just want to redraw to get the size correct.
Yes, sure. You can do it in two different ways. You can go to the attribute table, surf towards the one you misclicked. Like, for example, I do this one here. Open attribute table. I just went to the last one. As long as you select the feature you see that have been highlighted, and then you can click here to delete it. You see? Or you can do it also in another workaround. As long as you have this select features tool active, you can draw squares or you can just click. And when you have selected the features you want, you just need to, is over here. Okay. You just need to click the bin over here and it will be it will be erased. So you have two different workarounds for this. Here, if you want, this one here is a bit interesting. is an example of relative dating of the events. You have this crater here. Inside the crater, you have the boulder. This means that this crater is older. This crater over here, very small, is older than the crater that made the boulders roll towards this place. Just, I mean, maybe a funny thing. Geologist funny. Also this one here, same thing. You have a crater. This one is also useful to show you the difference in the shadows. You have something that is resting upon the surface, shadows towards the northwest, left side of the feature. This feature here is something that is encased into the surface, shadows on the southeastern side, right side of the feature. So something that is upon, something that is into the surface. I may zoom in a bit.
What would be, Sandro, your preferred mapping option? 2 points or 3 points? What is the most because 2 points is faster, way faster.
Way
But
faster.
maybe you have less control if you map along the shadow.
I don't think so, because I will go always for the second points, because most of the time you don't have regular shapes.
Yeah.
This means that when you identify a diameter, you are already making an assumption, an
Yeah, if it's
interpretation.
very, very elliptical, again, you are
Yeah, just for this
estimating the
example.
longer axis. Yeah.
Yeah, mapping this one here for the 3 points, I mean, what can I do?
Yeah, exactly like that. It's very, very difficult.
It's very difficult, So I will always go for the 2 points. Yeah. In this is the main problem of this task, because it may seem that is quite obvious, but the reason why there are no highly reliable automatic processes to do so is because you have a component of interpretation in this.
Yeah.
The
Actually,
V1 operator is fundamental.
this is very interesting because there are some machine learning algorithms that do that. Some of them are branching from those that were, for example, presented yesterday. There are some projects ongoing, not only for boulders, but also for craters. The problem of counting boulders with the automatic method is that essentially, as Sandro showed in this presentation early this morning, a boulder is consisting of two faces. One is hit by the sun and the other is in shadow and is casting a shadow. But if the boulder is not too big, the shadow that is casting is more or less equal to the sunlit area. So it's a bit symmetrical in a way. You will see in some cases when you do your counting here. And what happens is that if you train a model, it might exchange these boulders for impact craters because there's a sunlit part and a shadow part. Me myself, I was trying different methodologies, and in the end, you spend more time into cleaning false positives rather than actually doing the work by yourself. I am sure that we will get there at some point, but still, you need some degree of interpretation, also in cleaning up the let's say the counts. What these methods, automatic methods, might really help or might be good, for example, for a cross check, is they are able, like yesterday, Valentin Bickel was showing with the hollows, they are able to segment the image, meaning that they can outline precisely or quite precisely the shape of the boulder. Again, it's an inference. There's a degree of statistic uncertainty because there's the part in shadow. But if somebody wants them to make statistics on the shape of the boulders, this is another matter. But regarding their overall size and distribution, this is luckily or unluckily still one of the best methods, although it's prone to errors. This is why Sandro is issuing this project, because machine learning are high-level statistics, as Amanda said yesterday when she was talking about the generated maps with spectral information inside. And the statistics has some estimates of certainty, uncertainty, and errors inside. So let's say this is a balance or a compromise. I don't know, Sandro, you can complement what I say or correct me, but there are advantages and disadvantages in doing things in a certain way.
Yeah, you're totally right. Also, the reason why we didn't go for the crater mapping, I mean, at the moment still, is that we looked at the paper that have been already published about the automatic methods for mapping boulders and craters, and
And by the way, today there is a new talk about, I think, one of these papers for the new global catalog of the moon.
Yeah. And craters are very highly reliable, the automatic methods, compared to the boulders. So in our opinion, it was worth approaching a side of a topic that still has some possible improvements, that a topic that will be old in a few years, probably. I mean, maybe months. I saw some results from machine learning mapping of the craters, and are unbelievable.
Yes, you will see today. It's impressive, and so I suggest to stick around because it's really
sure.
it's really something. The thing is also, craters are, I don't know, I'm not saying they are easy, but they're more homogeneous in terms of shapes. Okay, they are circular or slightly elliptical, but there are some key traits that you can use. You will see today in the seminars. But boulders, essentially, they are fragments that can have very, very variable shapes. And so to train a model also for boulder fragments and their shape, it's like such a big endeavor that in the end you will get a much higher degree of uncertainty. And it's highly dependent on the target that is fragmented, on the substratum. Craters in a way are homogeneous and detectable because more or less the process is so high energy that the shapes are circular or semicircular. Then there are different levels of degradation, of course, but it's something quite different.
Yeah, also depends a lot in the location of the area you are testing. I asked you to start from the area on the south, because if you look at it in its entirety, you can see that it has a quite high density of boulders, so you don't have to move each time you map a boulder. But then if you compare to the areas that are nearer to the boundary of the rim, it is completely different thing. This area here is area number 1, and you can see it has a higher component of interpretation about this, because boulders are easily one side of the other, one next to the other, maybe a little bit overlapping one another, like for example here. And here you have to introduce your skill more than what you have to do on area to the south. So it is
By the
better
way,
to train here than move on.
we have here Ricardo Lagrassa connected, who is actually one of the developer of the new catalog for craters extracted with
Yeah.
with the machine learning methods, and I'm sure he's already having some ideas on how to to map these objects automatically. But Ricardo, if you're listening, like correct me if I'm saying something wrong or if I said something wrong about
Yeah,
the
yes, without any
machine
doubt.
learning.
Yes, you are correct.
Thanks. One interesting thing that I've seen about the Boulder, for example, in some of the models or in such irregular shapes, I don't know if the moment you're using also for the craters, but since they have some symmetry with respect to lightened or shadowed areas, one of the methods is to use a training data set of labeled boulders that they know because they have the ground truth that they are boulders. And then they rotate images by a certain angle. Each time, I don't know, 10 or 20 degrees, they take the same image, they make the first inference, then they rotate it, then it's rotated again and again in order to trick the software, changing the illumination condition. And only those results that are always in the same spot are considered reliable. Because, for example, some craters can be, I don't know, a crater is a depression. A boulder is something above the surface. So the shadows and the lights are exactly the opposite. What is in depression is the light. The shadow is on the opposite side with respect to what is raised from the surface. And this anyways can create some bias if the software doesn't know the exact illumination parameters. But if he has to guess the illumination parameters, it can be tricked and it can treat boulders as craters and vice versa, especially if the boulders are quite rounded and circular. There are ways to compensate this, but this is what is creating errors also in instance segmentation and all these kind of things. And also another thing that is creating error in instance segmentation, so in actually outlining the contour of the boulder, not as a circle, but with its actual shape, is that especially on the moon, we have some cases where we have very, very bright areas on the boulder. You see it in these images, and very dark areas. Dark areas essentially are a place where you have no data. And if you have no data, the software is not able to draw accurately the outline of the boulder. So either you can guess it, or sometimes it underestimates the contour or the shape of the boulder because it takes into account only the lighted part, or it overestimates because it takes into account also the shadowed part. So this is really tricky, and the model to train can be very, very, very complex. And again, correct me if I'm saying something that is not super technically right. Okay.
Also, if you want to add complexity, we are talking about the moon. We don't have any atmosphere here. But if you want to move to Mars or other sites where you have atmosphere, you have to account for all the noise deriving from the acquisition through a matter that is not the void. So you have distortion, you have hindering of your objects. On Mars, where you have a wind that move around the dust, you can have partial coverage of the boulders due to this kind of phenomena.
Yeah.
So here we started from the easiest possible choice, let's say. Also, if you go to the asteroids that are a rubber pile, let's say, all the boulders are one sticked to the other, and it's very difficult to me to decide where a boulder starts and where it ends, when starts the next one. So you have to add some interpretation, add some skill to your task.
We have a question, is more technical. After identifying a few dozen boulders, I got an insufficient memory error in QGIS, and then my screen went black, and I had to do a hard shutdown. I don't know if this depends on QGIS, because it's never happened to me, honestly.
I think it's more hardware related than
Yeah,
also
I think it
because
depends
the
on
project is quite light.
the small. Yeah. I mean, a shapefile with 1,000 of boulders is less than a couple of megabytes, so I guess it's
Well,
something else.
yeah.
Of course, if they start to be millions, it's something different. But if it's like 100 or 1,000, it is probably related to the amount of memory that you have in your computer and all the other things that are open. I don't know, Chrome with the webinar and all these other things. I shouldn't be worried. You shouldn't be worried too much about the size of the files you're working on in this school. We're particularly tailored to be as light as possible. Probably the heaviest ones are the ones for tomorrow's 3D lesson. Of course, by nature, 3D data are much more heavy. So they exceed the gigabyte of size. Of course, you can go wild into the creation of a DS project. If you load many layers at super high resolution, you can arrive to 20 gigabytes easily or 50 gigabytes, but that's not the case. We wanted to maintain light. So probably it's something that is related to combination of factors, but I don't think it's a few tens of boulders. It should be something different. So don't worry about the project.
I think it's more virtual memory than physical memory.
Mm.
It makes it the graphics or the graphic cardboard, but still, this should be quite light.
I can tell you that in less than half an hour, I already mapped myself more than 200 boulders. So
Yeah, basically that's the ratio when you have some skill. I mean, these are 40 and I made it in about, I don't know, 5 minutes.
so I am slow
Hmm?
with
Sorry?
respect to you. I am slow with respect to you, and
Well,
much slower.
I didn't be as much precise as possible, you know.
Also, the level of precision when you make such a high level of high statistics with so many data points, at some point, because we had a question before, the precision on how you are to map these boulders. Precision matters until a certain level, but then if you make such a high degree of such a high number of data points, the effect of the errors is going to be contained, because there will be some people that overestimate the boulder size and some people that underestimate the boulder size, and in the end they are going to be compensated in a way. Correct me if I'm wrong, but with such big numbers, there will be an intrinsic error, okay? Because of course you have a higher and lower threshold, and the data precision will oscillate between these two, but um, you will not overestimate the total number of boulders also in your mapping. I see also myself, some of them probably make it too small, some of them too large. Some of them you will miss them because you think that they are too small, but maybe they are good. Or some of the small ones you will map them anyways, and then they will be cut because in the cumulative size frequency distribution they are too close to the image resolution, and then they have no significance because they are not reliable. So there will be a threshold to cut the boulders in the end. So there are some methods to compensate for intrinsic errors in the mapping anyways.
Yeah, that's the thing. And also, I mean, if you're not a really skilled researcher, you can't trust a single, but you can trust a crowd. I mean, in these
Yeah,
cases,
maybe a
you have.
single does it completely wrong, but in the end,
Yeah, exactly. If you work on this, if your career is on planetary geology, then you are trained enough to trust you, let's say. And that's how most of the papers have been built. I mean, it's a single that covers a specific area, and then maybe more people, one next to the other, that covers a larger area, and their results should be comparable one another. But if you try to involve the people that are volunteer, are enthusiasts, that really like the topic but don't have a specific training about this, then you have to train them a bit and let them cover the same area from different people. And the comparison will give you a mean of the mapping and possibly a reasonable approach of the truth, approximation of the truth. But here, that's what we want to demonstrate. So,
Because then this can affect, of course, all the science that goes behind it. Because counting for the sake of counting is meaningless. But as Sandro showed, these methods have been applied into many bodies on the solar system, and they can have a different type of information. Because, for example, you can have failure like landslides or toppling of material. For example, I'm imagining the landslide or the cliff failure that was detected on the 67P comet by Maurizio Paiola, for example, or you can have information about the thermal fatigue and fragmentation of a specific material through time. I mean, for before, like in light and then in the dark, then in light and in the dark, you have some thermal fracturing and uh, thermal fatigue that can affect the fragmentation of a specific type of rocks, or different types of rocks that can have different types of fragmentation. So boulders, uh, let's say, generated from a certain type of rock can be smaller or larger depending on the properties of the rock. So how prone to erosion it is, how do they accumulate? Are they clustered, not clustered? Can you detect some? If you, for example, map eject arrays around the crater, and then you do it very carefully, you can detect if they are symmetric or asymmetric, and therefore, if they are asymmetric, you can infer if the impact was oblique, because oblique impacts higher than a very, very slanted impact produce a circular crater anyways, but they are still oblique. The difference is the distribution of the ejecta, which is asymmetric with an axis of symmetry along the direction of the impact, and this can give scientific information that is hidden in the data, let's say, or hidden in the image. So there are many ways to treat the data, but the accuracy and the reliability is the first step before doing all the calculations, the math and the science behind it. So yeah, this is to give a bit of perspective.
Yeah. Also, all the things that belong to the safety topic, let's say. If you
Mm.
want to investigate an area with a lander, you have to be aware of the coverage by those features that can represent a risk for your safety. So,
Yeah.
I mean, it's quite obvious when looking at this area, you don't want to go really near the rim and you can go towards more distant areas. But then how much distant? If you have a specific travel distance that has been designed for your rover, then you have to be as near as possible to be safe. And this kind of mapping can give you some hints about this.
Also, if you make some frequency distribution statistics, you showed some curves before. Essentially, having the curve of size distribution of boulders can help you also predict the size and the amount of boulders below the resolution threshold of the image. So you can estimate statistically the amount of boulders that you do not see. Because if they align on a power law, you can continue and try to fit the power law and predict the size of the boulders that you don't see in the image because they are smaller than the image resolution, so they are not detectable. Maybe they are just small pixels that you don't really understand what they are, but you can at least predict their amount. Maybe not their distribution, but anyways, you can make some inferences or educated guesses of what you should expect on the surface of the planet.
Yeah, if you look at the screen, Ricardo, if you want to go a bit of it in detail, the curve by Golombek about the coverage, the boulder coverage of the area. The curves are the theoretical coverage for 5%, 10%, 30, and 40% coverage by boulders. And these are the results of the mapping, but they go fairly beyond. I mean, this one, that is the test area that we went for, is basically the best possible place to start your career of boulder counting, because you have a fresh crater, a dark background where the clear, the lighten boulders can stick upon, and you don't have any atmosphere, you don't have any noise, you have a high resolution image of 0.5 meters, so you can really detect the boulders in the best possible environments. That account for all the, not this one here, for this limitation I placed before. So we have the best possible image. We try to give you a clear guideline, a clear workflow, and then we want to see what come out. What are the results of your mapping? Hopefully, you will be consistent one with the other.
Yeah, for sure, the small details will change. This happens in geological maps that are matter of interpretation also. You've seen many times during these days. There are degrees of interpretation. You've seen yesterday in the talk of Amanda Vergara Sassarini that she showed that some maps done by different operators, when you have to stitch them together, sometimes they do not match perfectly because some units were interpreted in a way or in another way, depending on the relationship with other units. And sometimes when you work on a frame, on a map, you just see what's in the frame. Of course, you have a broader context, but if you're not mapping all along a whole planet, sometimes you have some discrepancies. And this happens also when you do some statistics on feature distribution. There are the most prominent ones that are going to be mapped by everybody, but the devil is in the details, and the details might change from one to another. And you can have a person who is mapping thousands of boulders here, somebody who's mapping hundreds of boulders, somebody who is mapping just tens, because it's also a matter of precision, the way of approaching the topic, and the way to interpret things. For example, there are some features that I'm not really convinced they are boulders here. Maybe they are small, I don't know, other things. Some of them I think I have mapped anyways, some not, but the big numbers will make the difference then. When all the data will be analyzed together, there will be actually the result on how good is the human operator against the statistics, let's say.
Yeah, for example, here you have an example. This feature here is very bright, is very comparable, visually comparable with other boulders, but then it doesn't cast any shadow. So what is? It's a boulder that has been somehow covered by debris deriving from the impact. So maybe it arrives before the dust, or maybe it's just an outcrop that has been covered by the boulders that come from, but all the material that come from the impact. You can have some ondulation of the bedrock. You can see here that you have some lineaments. This one is it has a very large scale, but you can have smaller ones that can be confused with boulders. Also, you have some suspicious alignments. Are these boulders? Are these bedrock? Well, the single case we cannot really answer in this in this stage, but we can talk about the whole area because the statistic will absorb the specific problems related to a specific case.
Also, one of the problems of the boulder counting when you do areas, of course, you have to work on best possible images. And depending on when you do it, or how focused you are, how tired you are to watch the screen, you will get a different flavor or different sensitivity. And in fact, sometimes you work on really high details, but sometimes I suggest you to zoom out and zoom in to see the context, because you can start really detailed because you are fresh. For example, on the left-hand side of the mapping area, but as long as you proceed towards the right, you become more tired and then you miss more things. And so sometimes zoom out and zoom in just to see the context, whether makes sense with respect to what is outside the mapping area. This is true also for planetary mapping. So when I did my tutorial for QGIS, I said, please start to sketch the map first with mapping, with the source context, sketch it roughly, but at least you block down different types of units of terrains that you can refer by albedo, by the roughness, by how they relate one to each other. And then you go in and you start improving the details, modifying the context, then you regenerate the map, then you go more and more in detail. It's not a good idea to go in detail as the first thing. In this case, take your time to also look at the area, how homogeneous, how scattered they are, if you see that the boulders are more clustered on one side or on the other. And then from time to time, zoom out and zoom in and see if it feels consistent to what you observe outside. And it's like, if you're drawing a portrait of a person, you don't want to start from the eye or the mouth. You block down his shape first, because then you propagate the error, and then maybe your portrait becomes completely crazy. So it's the same. You have to always be aware of the context. And for the maps is to block down things and then improving the detail. And for this type of super high detail mapping is similar in a way, because you are looking at the same feature over and over and over, and then you might become tired, you might miss objects. And also, the more you see something, the more you're prone to something that Sandro called pareidolia, but can also be called confirmation bias. So the more you look for something, the more you start to see it. Although maybe it's not true, but you want to see it because you want to complete your task. And this is a very big problem in science in general, the confirmation bias, because sometimes you start a research or a mapping because you want to prove something, and then sometimes you prove it, although the data are not consistent. This is a problem, and we have to be as much objective as possible, as much constrained by numbers as possible. There's always a degree of interpretation in this type of mapping and in geologic maps, but having the context and relying on some codified workflows or codified objectives or strategies will help you to let's say avoid this tiredness or confirmation biases or pareidolia and so on and so forth. For example, if you were mapping maybe the whole image that we gave you, you cannot simply start from a spot and then proceed randomly. You should proceed more in an ordered, structured way. So if you were mapping the whole image that is in this project, so if you zoom out, Sandro, if you show us all the image, you don't want to start maybe on this specific square or close to the crater rim or just on the corner, but you should subdivide it into a grid which is reasonably sized, and then start doing some mapping on the grid elements one after the other, because more or less when you're finished with the grid element, and then you pass to the next grid element, and then to the next one, then to the next one, and then you review them. But there are structured ways to avoid big mistakes. We have a question for Sandro. Could you clarify, please? We should not or should count boulders in the big impact crater in the center of the map around the slope, not today or later. So essentially, can you repeat exactly what are the mapping areas that people should do to complete the task?
Okay, you have here a vector file that is called the mapping areas. You need to start from area number 2, that is that one that we are supposedly working now. And then next time, if you want to contribute to the project, you have to go towards area number 1. But then that's all. I mean,
Okay.
if you want to map all these craters, you will need quite a bunch of hours to do so. And we just want to compare the performance to test how are your skills, to test your consistencies. And these 2 areas is quite enough.
Yeah, and they are outlined. You see, maybe they're not very well visible in QGIS because, yeah, in the Boulder mapping, there is the Boulder mapping area, which is dark, I think.
Yeah.
So they're not very well visible, but these are the two areas, okay? So don't lose time on other areas, although they might look interesting, they will not be taken into account into this study. So focus just on these two pieces, the one on the south for today, and the one on the northeast for the project and certificate completion. You will see that the one on the northeast on the upper right side is also much more dense of boulders with respect
Yeah.
to this one, and it might take a bit more time.
Well, the area is smaller. We try to
Yeah,
be, let's say, since this one here is denser, much denser, and has some more complexity, we try to be a bit more small. Let's say the test area is a bit smaller than the other. So if you
for
have any
example,
doubts, just go for the mapping areas file.
yeah, I
And
see that they are more or less equal in terms of area and amount of boulders. For example, I have almost finished, I think, mine. I'm
yeah,
surely missed some of the smaller ones, but you see that in 1 hour, 1 hour and a half, you can do the task.
yeah,
So,
yeah, that's it.
and that's it. And then we will hear from Sandro again.
Yeah. Keep in mind that we want from you one shapefile for area number 2 and a different shapefile for area number 1. So when you finish the area number 2, you can upload the shapefile and leave the other for whenever you have time. You don't have to do it today. I mean, if
But
you're
can you
able
show
to
us maybe how to because we have only one shapefile for Boulder mapping. So the one of today is one thing. Either you start over with a fresh project, okay? Maybe this is my advice. So download it again from the
yeah,
Nodo. It's going to stay there. Nobody's going to delete it. It's going to stay there forever. And use the new project and map just the upper right side. So we avoid complications into deleting data and so on. This would be my advice.
yeah, this will be much easier for sure.
So start fresh when you want to do the upper right part for the contribution to the project. So for example, now I think I'm finished, so I will export the files and put them into the upload page.
Okay. So if you agree, we can. I don't know if it's a good idea or not to show them mine, just to avoid biases from the others. But
What? Sorry, my mapping, you mean?
yeah, no,
Ah, yes, I can show it, but very
I
quickly.
don't. I don't know.
No,
I
no, no.
mean,
Let's do it. Let's do it.
uh, you want me to close the condivision?
Yeah,
Screen
yeah.
sharing?
Let's. I will share mine.
Okay.
For example,
Just
this is mine. Okay, you see that I'm for sure I missed something, but overall, if I switch on and off, most of the brighter objects are covered. Okay, I think I missed some of the smaller ones here, but they are so small that probably are related to. This is 4 pixels. Maybe this is. I think I missed some of the elements, but uh, you can go a bit more in detail. But I don't think much more than this. All these smaller, very very small pieces um, are super small. These are 3 pixels, for example. You see, 3 pixels.
yeah.
This is maybe 4. This is
This
on the
may
on the
stick
verge
out,
of
but
the threshold. So maybe I can add a few more. I don't know, like something here, but they are really really small. So like this one, yeah, or this. This is already on the verge of not being considered then in the statistics. Also this one, yeah. So at some point you will start because you think you never finish because you see so many objects here. And sometimes you start mapping things that are not needed. All these things here are very small. Maybe this one is good. Maybe this one, but this one, who knows what it is? Okay. So I maybe missed some few points, but this is just for the demonstration purposes of today, and to get a grasp on how to do things. For sure, some details can be improved, but I suggest I can stop here in my case, and I will go here, right click, export. Okay, so I select my Boulder mapping, export, save features as. Do you see it? I don't think so.
Yeah, yeah, yeah.
Yeah,
Is it
you see
possible? Is it dark, but it's visible?
Yeah, okay. So right click, export, save features as. I select easily shape file, and then I find a name, and then upload on the platform. Okay.
Yeah, perfect. Thank you for sharing.
We have another question. Should there be a different file names for area 1 and 2 shapefile respectively?
If you can add a number, it will be perfect. But I mean, then when I download them, I will be able to see where the boulders are, so I can
Yeah,
do
the
it.
location.
Yeah.
One of the 6 files that you have to upload is the .prj, which is essentially the map projection, which also contains the location of the geometries that you are mapping. So better adding a number, but is, let's say, it's not super mandatory.
Yeah, it's fundamental to have the PRJ because we want to compare the location of each boulder from each person that mapped the area. If we are missing the projection, then or we have different projection, then all the mapping will be scattered around, and we will not have any possibility to compare the data. That's the reason why we have been a bit more redundant in giving you upload the 6 files, upload the 6 files, upload the 6 files, all of them every time. Otherwise, if you're missing something, maybe it's not something really important, but maybe you're missing the data or the projection, and everything became a bit more sketchy then. Oh, I see that Steve Teamers already did some. Wow, nice one.
I am going to share in the chat once more the upload page link for like clarity.
Yeah, if you want also to share the form, because when you finish your task, we would like to know if you had some problems, if everything went fine,
Yeah.
if we can improve somehow. I don't know if I can share also, but I think it is better if you do that on your own. Do you have the link or should I
Yes,
share
yes,
it?
I'm sharing everything.
Okay, perfect. Thank you.